Today we're going to talk about functions. A function is how you get from one set to another set. So a function f, say, from a set A to a set B gives, for every element in A, a unique element f of A in B. Hopefully that just about fits into the screen. So we start with an element in here, and we have an element in here. So we also write that as A gets mapped to f of A. And notice that this little arrow has a kind of thingy at the beginning of it to show that we're saying an individual element of A goes to this element. Whereas this function arrow has no little thing on it because it's saying this is a function that sends a whole set of elements to a whole set of elements, like this. So we say A is mapped to f of A, and the set that we started with is called the domain. Of F, and the set that we finished with is called the range. So let's have some examples of functions. Well, let's draw a picture, first of all, the kind of thing we can have. So if here's a set A, and if here's a set B, what we're saying is that here are some elements of A, they've all got to get sent to some elements of B. And you could send two elements to the same place, that's fine. What you can't do, you can't send an element of A to somewhere outside the set B. So you can't do that. You also can't send one element to two different places. So this element here, we couldn't also send it over there, right? That's also wrong. So we can't do that. We can send two elements to the same place. So let's just write that here. We can send two elements to the same place, but we can't send one element to two different places. Send one element to two different places. So let's have some examples of some functions. Okay, let me get rid of this picture, and let's have our first example. Example 1. We could take the set A to be the set containing two elements 0 and 1, and we could take the set B to contain four elements 0, 1, 2, and 3. And we can now define a function f from A to B by f of A equals A plus 1. So 0 under this function will go to 1, and 1 will go to 2. Okay, so notice that 0 went to 1, 1 went to 2, nothing goes to 0, nothing goes to 3. So if we wanted to draw this picture, we could go 0 and 1, and we could go 0, 1, 2, 3, and we'd have 0 going to 1, 1 going to 2, and nothing going to 0 and 3. So each of these goes to precisely one place, but maybe something over here doesn't have anything that hits it. Whereas you can't have something over here with no arrow coming out of it, because everything over here has to go somewhere. So this is a perfectly good function from A to B. Another perfectly good one that we could have from A to B here would be g of A equals 2a. That's a perfectly good one as well. So this function gave that answer. And this one gives 0 will go to 0, 1 will go to 2. So still, not everything will get hit on that side, right? Nothing will hit 1 and 3, but that's okay. All right, let's have another example. Okay, I'll take this off now. Here's a slightly more interesting example. Let's take A to be the set 0, 1, 2, and 3 this time. And let's take B to be the set 0 and 1. And this time what our function is going to do is it's going to give us the remainder of a number after we've divided it by 2. So imagine that you don't know how to do fractions anymore, so if something isn't divisible by 2, when you take the remainder you're just going to get 1. If it is divisible by 2, then when you take the remainder you'll get 0. So this is going to be f of a is the remainder when dividing a by 2. Okay, so we have 1, 0, 1, 2, and 3. 0 goes to 0. 1 is odd, so when you divide it by 2, you'll get remainder 1. 2 is even, so you get remainder 0. And 3 is odd, so you get remainder 1. So in this case, we've got 0, 1, 2, and 3. And we've got 0 and 1. And 0 goes to 0, 1 goes to 1, 2 goes to 0, and 3 goes to 1 again. So in this case, we've got two different numbers both going to 0 and two different numbers both going to 1. But that's okay. So we could do this again. So we could take B to be 0, 1, and 2, and we could take A to be a much bigger set, right? So we could take A to be all the natural numbers. We could take B to be 0, 1, and 2, and we could say that f of A is the remainder when we're dividing by 3 now. So it's the remainder when dividing A by 3. So now what's going to happen? This should be n including 0. I want my 0 to be in there. So 0 will go to 0. 1, well, the remainder, if you try and divide 1 by 3, and you don't know how to do fractions, you'll get 1. 2 goes to 2. 3, however, will go to 0. Right. Now 4, if you divide by 3, you'll get 1 remainder, so that's 1 again. 5 will go to 2. 6 will go to 0. 7 will go to 1. 8 will go to 2. 9 will go to 0, and so on. So this just cycles around. 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. So that's a perfectly good function. You'll get lots of numbers going to each number over here. Every 3 numbers will go to the same place over there. And this function is very important for something that we'll see later. Perhaps I should stand over here, which is modular arithmetic. So we can do this for 3, 4, 5. We could do this for dividing by any number that we want. But we'll see some more about that much later.